Alright, we're going to work on some problem solving today. This is using that stuff we know already about supplementary, complementary angles, about vertical angles, etc. to solve problems. Number 1 says a complement of an angle is 3 times the measurement of the angle x. So the first thing I'm going to do is I'm going to say, oh, they've given me a name for an angle. The angle is going to be called x. Find the measurement of the angle and its complement. This word complement comes from complementary. It means that x and the other angle will add up to 90 degrees. So we know a couple things. We know we have angle 1 and we're going to call it x. We have a second angle. And what we know about the second angle is it's 3 times the measurement of the first one. So the first one is x, so I can write angle 2 as 3 times x. The other thing I know is that they're complements of each other. That means my first angle and my second angle should add up to 90 degrees. I need to know the measure of each angle. So my plan, that's a good plan right there. I'm going to go from here. Whatever my first angle is, and my second angle, when I add them up, I get 90 degrees. Let's combine similar terms. I have 1x, it's like an invisible 1 out in front, 1 of x, and 3x. Altogether, that makes 4x. Now I've got a one-step equation. I have 4 times something gives me 90 degrees. To undo, multiply by 4, we're going to divide by 4, and I like to use my fraction bars. 4 divided by 4 is just 1x, and 90 divided by 4 is 22.5. Alright, I've solved for x. Am I done? Now I've got to find the measure of both angles. So there's 2 options to find angle 2. First of all, I know angle 2 is 3 times my first angle, so I could just say 3 times x is 3 times 22.5, and that's just 67.5. The other thing I could do is I could have said, well, I know they have to add to 90, so let's do 90 minus 22.5. You'd still get 67.5. Whatever method you choose, you can use the other method to double check you did it right. You can say, well, if I know they both have to add up to 90, let's check, see if I did it right. Let's see, that's 1, 1, 2, and 7 is 10, 2, and 1, and 6 is 9. That works out. So my solution, I have 2 angles. My first angle is 22.5, and my second angle is 67.5 degrees. Could you have drawn a picture over here to accompany what you're doing? Yeah, I guess so. You could draw yourself a 90-degree angle and split it up. X over here, maybe 3x over here. Made some note that it's 90 degrees. But you didn't have to. But we're in luck, the rest of these problems already have a picture with them. Let's look at number 2. 4 rays meet at a common endpoint. Write and solve an equation to find the value of x, and then determine all the angle measures. So I've got 4 angles. What I know about them is angle W is 36 degrees. I know that angle Z is special because there's this little box drawn in the corner. So I know my angle Z has to be a 90-degree right angle. Then I have 2 more angles, angle U, which is 2x, and angle Y, which is 7x. And the other thing I know is I have all these angles. Basically I have 1, 2, 3, 4. They're all coming into the same point, the same intersection, really. So I know they all add up to 360 degrees. So like I did up here, I can write an equation that represents that if I want to, but I might save that for my plan space this time. I need to know the measure of all angles. I've already got 2 of them. Great. Let's work on the other 2. So I know when I go and add these 4 up, I'm going to get 360 degrees. So an equation for that might be 36 degrees plus 90 degrees plus 2x plus 7x equals 360 degrees. If I add these 2, let's combine similar terms. 36 and 90 is 126. Yep. And let's combine these 2 guys as well. 2 plus 7, that means I have 9 total x, and then that still equals 360. I want to get x by itself, so let's start by taking away the constant piece over here so we can move it over to this side. 126 minus 126 is 0. What's left is 9x. And I gotta do the same thing on this side. 360 minus 126. Let's say 4, 3, 2. There we go. Now I want x by itself. I have 9 times x. Let's divide by 9. 9 divided by 9 is just x. 234 divided by 9. Let's see. I think it was, well, let me do a little. Let's see, it goes in twice. It's 18. We're left with 54, and that is 6. There we go, 26. That's what I remembered. I wanted to double check. Alright, is that my answer? No, I'll need to find the measure of the angles, but I know what x is. It told me to do that, so now that I know what x is, I can find what u and what y are. So 2 times x, that's 2 times 26, that's 52. And 7 times x, that's 7 times 26. Let's see, 7 times 6 is 42. 7 times 2 is 14, that's 182. Alright, my solution. We know that one, we know z. We just learned that u and y, that's supposed to be a y. 182, there we go. It's interesting to note this drawing is not to scale. If angle y is 182 degrees, it would not be folded like it is, like that. It would be folded like that. It would be slightly larger than a straight angle going that way. So this guy's not to scale. And it's important to know that they're not always to scale. Sometimes it's just a sketch. Sometimes it might look like it's a right angle, but if it doesn't have this in the corner there, we don't know for sure it's a right angle. So it's careful, be careful. Same with 180 degrees if it's a straight line. And, well, if you have other information, use your other information. I guess that's what I'm trying to say. If somebody looked at this and said, well, it looks like this is 90, that's 36, that's kind of almost the same as a 36, so maybe this guy over here is kind of a little less than 180 because of how it's shaped. No. Go with the things that it tells you. If you have to make an educated guess, like on some of the old problems that were in the other papers, where there's a line and a single ray coming out of it, and you can assume those are going to add to 180, then do so. But be careful about your assumptions. That's it.